My name is Bailey Steinfeld. I am a senior firmware developer and product manager here at Dojo 5. Today, just going to talk about the, we call it the art of reading code, but how to read code, how to get into it, how to give feedback, and how to make your code easier to read. At the end, we'll do a little bit about troubleshooting and asking questions as well. If you need me to, just to answer any questions, raise your hand or unmute and shout at me at any time. I do like conversation more than being on a podium, so happy to have a conversation. Okay. All right. I want to talk about reading code today from two different perspectives. One, if you're approaching a code base for the first time, and the other, if you're doing a code review or for a PR for somebody, or a code review for a code base in general. In school, they teach you a lot how to write code, but not so much how to approach it when you're seeing a large code base for the first time. A lot of our new engineers see codes bases that are orders of magnitude larger than what they saw in college, and it's overwhelming how to approach it, how to get into it, and where even to start. So when you're approaching for the first time, README, if they have one, is always a good place to start. If there's an excellent README saying what tools you need installed, what the code is doing, what different blocks that are doing, that's awesome. However, not many code bases will have that unless they're really well supported open source. We suggest you open up your code in an IDE or another editor that understands the declarations and can do syntax highlighting, fold things down for you so you can squeeze the code down into just the headers and stay high level. If you're in C++ or C, stay in your H files, just see what things are being called and don't get mired down in details of what exactly each function's doing at first. Finding an entry point would be another a good point to start. If you're in C, it's going to be your main function in a main.c file normally. If you're an Arduino, it's an INO file, and they'll have a setup and loop. Python will have the package name will often have its own file. There'll either be a main function or the top of the file is where that'd start. And then if you're in C#, like I was for a long time, there's an on startup or a main function in there as well. Look for those things, see where it starts, and start just looking through what's called and drawing yourself a little sketch or diagram, block diagram of where code's going, how things relate to each other, what happens at one time. And if that's you're looking at it for the first time because you're going to start developing with people, looking through the recent commit history and active branches in the repo is also a good thing to do. You'll see where active work is going on, what other people happen to be looking at, what's changing, and it might give you hints on what parts of the code are most important. There's going to be things you want to ignore, though. Anything that can be automated, you don't want to get caught up in, oh, they put the brackets in a different place than I would, or if you're looking at the commit history, there's usually a way in web editors or the web viewers in GitHub and GitLab to hide the white space changes, so you can ignore those as well. Don't look for unused variables, dead code, other things that linters will pick up. That can all be automated. Don't worry about it for review. Don't worry about it for trying to figure out what this is doing. You can also usually ignore submodules, libraries, external components, because those aren't going to be the main point of the code that you're looking at right now. Then the other aspect of reading code you're going to do all the time is reviewing PRs. So again, look for differences that aren't white space. set to ignore white space if you're looking at GitLab or GitHub. Suggests that your team starts separating your reformatting changes into separate commits, so you can just skip that commit when you're looking at the any PRs. Look for comments, both in code, the commit messages, and in the PR itself. Those are going to be tell you what they were doing, what their intent was, and what kinds of things that they, or why they changed the things they changed. If it's a really big diff, maybe look at individual commits so you can see their thought process and small changes individually, and that can help you review each of those components and changes rather than the entire diff at once. The most important thing, though, is when you're doing a review, don't modify the code. You're wearing a review hat at this point. GitLab has a section to make code suggestions. So if it's hard to write out what your suggestion is, you can make a code suggestion and show the change there, but don't modify the source. Other things to look at, check against the requirements and determine if this code meets them. Check that your standards are met, if things have been tested, if they've gone through all of the steps of your process, which is easier if you have a CI/CD system, but if not, you'll need to make sure that they did their CPP check or linters or documentation steps. This is where you do want to look for anti-patterns, code style changes, and other things like that. Then when you're giving feedback, make sure you keep it in scope for that PR. If you do see other things that you have notes on, note them down and bring them back up outside of that pull request. Give suggestions about what problems may be caused by the code, but make sure to communicate that humbly and don't blame anyone, especially if you're giving a PR for a new code base that you're not familiar with. We do a lot of consulting, so if we see changes from the client, they have way more in-depth knowledge of that code base than we do. So something that may look fishy to us may just make sense in there or have more history than we know about. So you can point it out still, but communicate humbly and remember that there might be other factors that you're not seeing just in that PR or the code. Then make sure to organize your feedback in order of importance. It's tempting to leave it all chronological and as you found it, but put the things at the top that are going to be most risky, need the most attention, and go from there and filter down. If you're reviewing an entire code base, as we've done sometimes doing audits, you may need to split into priority levels and give a summary of why you did so and what each of those levels mean. So things that will affect security or performance at all at the top. Things are just code style changes, suggestions for improvements or efficiency closer to the bottom. So how do you make your code easier to read? Because it's not just going to be other people reading it, you're going to have to go back and read it too. We talked about READMEs at the beginning. Like I said, a lot of code bases don't have great READMEs. We're starting to refine our template for ours so that we have standards of information on every repo. So you can say what a developer needs for tools, what other external dependencies this needs, where to get started, how to run it, how to flash it to boards if you're using hardware like we often do, and any other information or like data sheets or external information that is just helpful for the newcomer to your repository. Comments and documentation, beyond the README, if you're working on medical devices, you might have to do something like Doxygen, but in any case, documenting what each function does and putting comments in for why you made decisions is always good. There's a fad for self-documenting code. I do believe it's good to use variable names that explain what they are and that, but you still sometimes just need regular English to explain to somebody what each code block is doing, or the file in general. Make sure your commit messages make sense. Don't just say made a fix, say what fix you made. When you're making your pull requests, make sure that you have in there what the intent of this pull request is for, like what the problem you're fixing is, the feature you're adding, the refinement you're making, why are you asking for this to be pulled, why you made the decisions you did. So there's multiple ways to solve things often. So why did you choose your way? What got in the way of choosing a different way is always a good one too, especially if there's a normal or standard way to do something and you didn't follow it. That's a great thing to put in your pull request description. And making small frequent commits always helps to see what your thought process was and where changes were made and when. I'm going to take a pause here. That's my section on reading code. Next, I'm going to go to troubleshooting. So pause and see if you have any questions or comments. Okay. Next up, part of reading code is troubleshooting. I see a lot of new developers out of school, and I'm sure I was one of them. It's just been so long, I forget. That troubleshooting is a hard thing when you come out of school. The only code you have to troubleshoot is the stuff you just wrote. So finding something that's broken in a larger code base may not have been written by you, or just has more complexity than you're used to, is new for a lot of younger developers. So troubleshooting sometimes gets to be sticky. First to write down is just all the symptoms, not just, well, it's breaking, not working, but what is it not loading? Are we having a hard fault? When does it happen? Does it happen every time? And ask, what do you know? And what are you assuming you know? That's a big one. I know earlier this week, I was troubleshooting some code where it was telling me that the branch couldn't be found in an automated pipeline. Or not the branch couldn't be found, the commit couldn't be found. And that was confusing because, well, it worked on the same code base, the same automation code before. What happened? So what did we know? Well, it was definitely pulling the code correctly because it changed branches just fine. So the repository seems to be intact. And then what were we assuming? That our regular expression that we wrote was correct. And that ended up being the problem. It was not written to find SHAs correctly. So, but assuming we didn't know the regex was correct, we could know that our code was getting to the point of where that was reading, but we were assuming we knew at the regex. So looking through and making sure that you actually have proof for everything you're assuming is a good place to start, and turning your assumptions into knowledge. Like if you're assuming it worked all the time, can you go prove that or see exactly when it stopped working? And note what you're trying to accomplish when you first noticed the problem. Maybe this code did work just fine, but now that you're doing something new with it, it doesn't work in this new instance. So look for, when did it work correctly? Has it worked correctly before? Did the build or the target system change in any way? What has changed in code since it did? And sometimes the immediately obvious thing going wrong is not what's actually broken. In my example of that automated pipeline failing, the error said that the commit wasn't found or there was no commit. So your immediate assumption was, oh, the repo must not be getting to the runner correctly. It might not, the repo is broken, but that ended up not being the case. It was bad code. Then when you're reading your code and you've considered what are possible causes for the issue, that's where your code reviewing skills come in. Being able to build that structure around and have a picture of how the code works together and seeing where things could break. If it's a recent issue, go through commit history and see what might have touched it or change things near or that called within that structure that you're seeing. Prioritizing. Sometimes you won't prioritize fixing the most likely thing. You'll prioritize checking the easiest to check. So things that you can very quickly eliminate as potential problems, always good to do early on. And then start going from likely and easy to check and from there. Then when you're testing fixes, that's when small frequent commits make even more difference in what you're doing. Also, remember to document what you've tried and the results. I do remember troubleshooting a few times where I tried the same thing two or three times just because I had forgotten what it turned out as when I tried it. So when you try something, remember to document that you tried it and what happened when you did it. Try to write new unit tests if you don't have any unit tests at all. Or unit test for this thing, see if there are some unit tests, integration tests, something that you can write to add to that. So if this breaks again in the future, it'll be easier to identify and make sure that you know you fixed it correctly now. Sometimes we'll write simpler sample apps, especially for things that don't happen frequently, just to make it happen more often so you can troubleshoot faster and try new things faster. Or to break it out from a more complex process so you don't have to spend time getting to the point where the error happens. So if you can write a small sample app or test just to test that part of the code that's bad, that can speed you up too. And then when you make the PR for that commit, make sure you communicate what was wrong, how you fixed it, and especially if it's a mistake or issue that could be easy to make again. So when I made my regex mistake, since we do stuff with pipelines quite frequently, I documented the correct regex for a SHA-1 and put it in our internal documentation and pointed out on our internal channels that that was something that we needed to look at. Sometimes you're just going to need to ask for help, either if you're writing new code, reading new code, or troubleshooting. When to ask for help, there's no real set timeline, but a good guideline is to give it a few minutes before even looking at any Google searches or going to the internet, Stack Overflow, anything like that. Sit with it for a few minutes and try to get a good mental picture of it before you start. And then about 15 to 30 minutes before you go bug another developer nearby. Because the first thing they're going to ask is, well, what did you look up first? Like, what did you try? And if you can, try to get a few questions grouped together, not only so that you're interrupting the person a little less, but so they get a better picture of what you've been looking at and what you're trying to solve. The XY problem down here is something you'll see on Stack Overflow a lot, but I've also done it and I've seen it from other developers I've worked with. Somebody looks at something, decides they know how to, or they have a solution to fix it, and then that's not working. So they go ask, how do I use this thing, or how do I do this thing to fix my problem? Well, if you get that question, you should be asking why. Why are you doing it that way? So a better question to ask is, do you know good ways to solve the problem I'm having? Not how do I finish the solution I've already decided upon. So when you're asking for help, make sure you're formatting your questions that include your end goal and what you're trying to solve, and not just the implementation that you're already working on. And again, if you're being asked that any question about how to solve something, ask why several times, at least 3 times, about why you're doing that. What's the purpose of that? Just try to get past this problem of making sure you're asking the right question. I know that was super quick. I know I tend to talk fast. If you have any questions, I'm happy to answer them now. If you would like code audited or reviewed, we'd be happy to do that too. And we did make a handout for this, and I can email it out to you. Either tell me now or email us at this email, and I'll get that to you with some tips and tricks on how to, or things I've talked about today, about how to read code and give feedback and do some troubleshooting. So, well, hearing none, thank you for coming today. I hope I was helpful, and I hope to see you again in a webinar soon.